Today we're going to talk about maps. A map is a new type of container that works in a very different way than the types you've learned about so far. Instead of just being a list of items indexed by consecutive numbers, like a vector or an array, a map stores a relationship between two types of items: keys and values. You can think of it like this: each possible key represents a box, and there's one value in every box. In this case, A, B, and C are the keys, and the map contains 5 at A, 3 at B, and 8 at C. If you try to access a key that isn't in the map, like D, you'll get an error. There's no restriction on how many times a value can appear. For instance, both B and C can contain the same value. However, each key can only correspond to one value. I couldn't, for instance, have one instance of the B key corresponding to two different values, or two separate instances of the same key. Maps are very useful when you want to look up something other than just in-sequence integers. For instance, you might want to keep a dictionary of all the words in the English language that you can look up definitions. Another example is in the context of robotics. It happens when you have multiple robots. You might have different IDs that you want to use to look up each of your different robots, so you can refer to them by ID. Finally, an example that we'll see fleshed out in a little bit is the idea of a word count map, where the keys are strings, words, and the values are integers representing how many times each word has appeared in the sentence. Now let's look at some code. The type of a map looks like this, with the key type and the value type listed between the angle brackets. This creates an empty map, which isn't very interesting. Let's initialize it with some values. Just like with a vector, we can iterate through a map, like this, using ranged for. However, now instead of just iterating over values, we're iterating over pairs of keys and values. We can access the key with dot first and the value with dot second. Now let's run this to confirm that everything is working as we expect. And we see all of the numbers listed in order, but they're not quite in the order that we expect. When you put a number into a map, or anything into a map, it'll actually sort them by keys. So in this case, it's sorting by lexicographic or alphabetical order. So that's why we have 8 before 5, and then 4, and then 9, and so on. Like with a vector, you can use the indexing operator to access the items of a map by key and to insert new items. Here I'm adding the value 10 at the key 10 in the map. As we can see, when I run it, 10 will appear in the output. You can also access values with the indexing operator. So, for example, I could print out the value at number representations 5 plus the value at 4. And because both of these items exist in the map, it should give me, as expected, 9 here. However, you have to be very careful with this syntax. If you try to access a value that doesn't exist, like 11, it won't tell you anything is wrong. It'll silently fail, but even worse, it will insert the value into the map. This can be a real pain to debug. If you already know an item is in your map, you can use .at. Just like this. If you have an issue where you're trying to access a key that doesn't exist, like with 11 earlier, it will simply crash your program. And you can't see it on this website. We can also use this syntax to write variables. So for example, I could say .at 11 equals 5, except 11 will crash, so let's say 5. And I could change the value of 5 to 6 instead of 5. And here we see 5 now corresponds to 6. Now, if you want to know whether or not an item is in the map, you can check with .count. Here we should see 10 should return 1, and calling the same function on 11 should return 0. And we see 1 and 0 as we expect. There's one more example of a program using stdmap that I'd like to talk about, and it's probably a lot more useful than some of the other ones we've talked about. I mentioned earlier that you can build a word counter, and it's actually fairly simple. We'll start by declaring a map using strings as keys and integers as values. So let's make our function and call it word counter. And it'll take in a vector of strings. Now, we want to iterate through each of our words, but first let's create the map that we're going to return. And we can use ranged for, just like you've seen earlier, to iterate through all of the words. Now, for each word, we want to check whether or not it's in the map. If it is already in the map, that's great. We just need to add the value. Remember that count returns how many times it finds the item in the map, either 1 or 0. So if it's greater than 0, we want to increase the value by 1. And if it's not, we can insert a new value in. So we can say result word is equal to 1. Now we want 1 because now we've seen the word once. And that's actually all there is to it. Now we'll have a program that will iterate over each of the words. Let's actually run it by creating a map. And running our function on it, and we can real quick iterate through everything. And that should do it. Now we can run the program. And I'm getting some errors. Let's see what these are. Well, one is because I made a typo here and forgot to actually write out map. I think the majority of them are just that. So, there we go. We've got our word counter. And you can see that all of the words except best and worst in that sentence occurred twice.